Alright, so in this video, I'm going to be solving the problem 2 to the power of 24 minus 1. So, for my solution, what I'm first going to do is rewrite this as 2 to the power of 12 times 2 minus 1. So all I did was I rewrote 24 as 12 times 2. And now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2, I can rewrite this as 2 to the power of 12 to the power of 2. And now 1, I'm going to rewrite that as 1 squared. So now I have 2 to the power of 12 to the power of 2 minus 1 squared. And now I can use the property that states that if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is 2 to the power of 12 and b is 1. So I get 2 to the power of 12 plus 1 times 2 to the power of 12 minus 1. Now from here, we need to find the value of 2 to the power of 12. Well, 2 to the power of 10 is equal to 1024. So this means that 2 to the power of 11 is equal to double of 1024, which is 2048. And 2 to the power of 12 is equal to double of 2048, which is 4096. So now I have 4096 plus 1 times 4096 minus 1. 4096 plus 1 is 4097, and 4096 minus 1 is 4095. Now, how would I solve this? Well, what most people would do is try to solve this by using the basic multiplication method, but this takes way too long. So a better way to solve this is actually to rewrite this as 4,000 plus 97 times 4,000 plus 95. Now, because 4,000 has so many zeros in it, it's much easier to solve this problem. So I'm going to be solving this problem by distributing. Or what I can also do, which is an easier method, is to rewrite 4,097 as 4,100 minus 3 times 4,100 minus 5. And this is also another way to rewrite this time subtraction instead of addition. But now, notice how we have 3 times 5, which is much easier to solve than 97 times 95. So now, I'm going to distribute my 4,100. So I get 4,100 squared minus 5 times 4,100. And then now I have minus 3 times 4,100 minus 3 times negative 5. So now, 4,100 squared is equal to 41 squared plus 4 zeros. 41 squared is 1,681, so I'm just going to add 4 zeros to the end there. And then minus 5 times 4,100, I can just say this is 5 times 41, which is 205, and then add 2 zeros. Minus 3 times 4,100, which is 123, and I can add 2 zeros. Minus 3 times negative 5, which is positive 15. So now from here, I get 16,810,000 minus 20,500 minus 12,300, which is equal to negative 32,800 plus 15. Now, a negative number plus a positive number is the same thing as 32,800 minus 15, which is 32,785. So now I have 16,810,000 minus 32,785, and this is equal to, I'm actually going to write this like this. So 10 minus 5 is 5, 9 minus 7 is 2, 9 minus 8 is 1, 9 minus 2 is 7, 10 minus 3 is 8, 8 minus 1 is 7, and I have 6 and 1. So 16,787,125 is my final answer to this problem. Alright, so in this video, I'm going to be solving the problem 100 to the power of x is equal to 10 to the power of x plus 1 to the power of x. So, to solve this, what I'm first going to do is rewrite 100 to the power of x as 10 squared to the power of x. So now this is equal to 10 to the power of x plus 1 to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So 10 to the power of 2 to the power of x is equal to 10 to the power of x to the power of 2. So now I have 10 to the power of x to the power of 2 is equal to 10 to the power of x plus 1 to the power of x. Now, if I have something in the form, 1 to the power of any number is just going to be 1. So we can just get rid of this x as an exponent because it won't really change anything. So now I have 10 to the power of x squared is equal to 10 to the power of x plus 1. And now from here, I'm going to let 10 to the power of x equal to the variable m. So now I have m squared is equal to m plus 1. And this turns into m squared minus m minus 1 is equal to 0. Now I'm going to use the quadratic formula to solve this. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get m is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4a is which is 1 times c, which is negative 1, all over 2a, so 2 times 1. And this turns into positive 1 plus or minus the square root of plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So this is the value of m. And to be precise, the two values of m are 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. Now, remember how we let m equal 10 to the power of x. So 10 to the power of x is equal to 1 plus the square root of 5 over 2, and 10 to the power of x is also equal to 1 minus the square root of 5 over 2. So for my second equation over here, 10 to the power of x is equal to 1 minus the square root of 5 over 2. Well, 1 minus the square root of 5 over 2 is a negative number. And you can't take the power of a positive number and make it equal negative, meaning there's no solution to this equation. So we are only left with 10 to the power of x is equal to 1 plus the square root of 5 over 2. And to solve this, I'm going to take the log on both sides. So I get log 10 to the power of x is equal to log 1 plus the square root of 5 over 2. And if I have something in the form log a to the power of b, I can move the exponent b to the front, so this turns into b times log a. So now I have log 10 to the power of x, which I can move x to the front, so I get x times log 10 is equal to log of 1 plus the square root of 5 over 2. And now I'm going to divide both sides by log 10. So then these two cancel out, and I get x is equal to log of 1 plus the square root of 5 over 2 over log 10. And log 10, if you guys already know, is equal to 1. So this turns into log of 1 plus the square root of 5 over 2 over 1, which is the same thing as log of 1 plus the square root of 5 over 2. There's no need to include the over 1 because anything over 1 is itself. So this is my solution to this equation.